Hello and welcome to Go Any Last Hello and welcome to Go Any Last Words, a podcast for air cadets. This is CI me.
And this is Sergeant White.
What are we learning about today?
Well, you know, in the last podcast we did, we talked about the moon quite generally. So we talked about lunar eclipses, solar eclipses, the dark side of the moon. This week, we're going to go a little bit deeper. I'm going to be discussing lunar science and asking the old age question, could we ever live on the moon? So I'm just going to jump straight into the content, if that's all right, because this stuff is fascinating. I just want to get started.
I mean, what else would you do?
I mean, we could talk about hats. Let's get into the podcast. It's always been a dream for us, the human race, to walk on the moon. And that dream became a reality in 1969, when the first astronauts walked on the lunar surface as a part of the Apollo
11
mission.
Yes.
Very good. And then subsequent Apollo missions put others on the moon, and 12 American males have visited in total. So one of the aims of the Apollo programs were to carry out a set of scientific experiments and just conduct a real deep exploration of what the moon was all about. So what was it made of? Where did it come from? How did it come to be? And since the Apollo program, many unmanned vehicles have landed on the moon to conduct more scientific experiments. So we've not needed to be there. We've been able to send out machines to do our work for us.
Safer, cheaper.
Exactly. So the moon can give us clues as to how the Earth was formed, as the craters on its surface are perfectly preserved. So there's been no erosion, there's been no earthquakes or landmass changes. So the craters that exist on the moon, as we know them now, they existed exactly like that when the moon was first formed. And that can give us...
Interesting.
It really is interesting. It's like a time capsule.
Well, maybe now that Buzz Aldrin's footsteps in it, probably not perfectly
Well, he's
preserved.
ruined it, hasn't he?
Yeah.
God. But yeah, it can really give us more information as to what happened at the beginning. And most of the craters on the moon are actually 4 billion years old and were formed during a period called the Late Heavy Bombardment. And that was when comets, asteroids, and other objects hit the moon and the Earth. On Earth, volcanoes, earthquakes, and erosion has constantly changed the surface. So what the Earth looks like now looks completely different to how it did when it was first formed.
Yeah, continental drift.
Exactly, continental drift, tectonic plates moving and colliding, causing earthquakes and
continental drift.
Exactly, and causing tsunamis. And this kind of these natural processes haven't happened on the moon. So studying its composition and surface can give us clues on what the Earth might have looked like as well, billions of years ago. So lunar samples were brought back during the moon landings of the 1960s and 70s. Now here's a fun fact here. In total, Apollo astronauts collected 840 pounds of lunar material.
What's that in kilograms?
I don't know what it is in kilograms, but I know that it's the equivalent of the weight of a Shire horse.
I can't say I've ever picked one up, so I can't say it's got me any closer.
But they've got to be heavy, haven't they?
Yeah, hefty.
They've got to be heavy. So that's a lot of lunar material that we've brought back. And during an Apollo 11 mission, the team were charged with collecting lunar surface materials without contamination. Now, as hard as they tried, all of the samples that astrobiologist Andrew Steele inspected were contaminated with brush bristles, bits of plastic, Teflon, nylon, and even biological material from the astronauts themselves.
Is that like a snazzy way of saying like skin dust?
I think so, yeah.
Biological material.
Yeah. Bits of human. And the even the bags that the team stored the rocks in were also a major source of contamination.
Yeah.
So when the rocks were studied, it was found that they have many chemical similarities to rocks found on Earth. And this suggests that the rock on the moon is historically linked to the rock found on Earth. Further analysis also showed that the moon rock is about the same age as the rock found on Earth. And one of the main differences is that the rocks on the moon have much less water in them than the ones on Earth, which gave even more info to NASA scientists about how the moon was formed. Now, we may have all heard of the Big Bang, but the theory that the Apollo program has theorized is called the Big Splash.
Oh.
Have you heard of that?
No, I haven't.
Or the Giant Impact Hypothesis.
Okay.
The Giant Impact Hypothesis states that the moon was formed by a massive impact between a planet a little smaller than the Earth, called Proto-Earth, and an object about the size of Mars, and this object no longer exists. It is believed that the small object hit the proto-Earth at a grazing angle. Do you know what a grazing angle is?
I'm just going to guess like an angle of which would graze off some rock.
I tried to understand what grazing angle meant, but then we started jumping into the angle of incident, all these mathematical terms which I don't understand.
I thought it was the adjective. Like a grazing angle was an adjective.
Apparently it's a mathematical term.
Oh, okay.
Which I didn't know. So the simplest way to explain it is to imagine the object approaching the Earth nearly parallel to its surface.
Okay.
So the angle with which it is approaching the proto-Earth is basically an extremely acute angle.
Yeah.
So it sort of grazes along the surface. So I think what you said was pretty similar.
Yeah.
That's the simplest way I can explain it.
Just grazes along it.
Yeah, exactly.
Takes off like the top hairs.
But it was an extremely powerful impact. Yeah. And this grazing incident's collision sped up the proto-Earth's rotation and melted the mantle inside the Earth, causing it to reform. And most of the smaller planet, the proto-Earth, fused with the larger body, forming the Earth.
Right.
And the impact blasted a small fraction of material into orbit, giving Earth Saturn-like rings. So Earth used to have rings around it, which I didn't know. But those rings were unstable and later clumped together and compacted under their own gravitational force from the moon. So
we had a moon and we had rings at the same time. And then the rings left and floated off.
I'm not sure if they were all around at the same time as we know them today, but what we do know is that at some point the Earth did have rings, and the Earth and the moon probably formed from this impact. But I don't know if they were how they are today, but I think they must have existed at the same time.
If the moon's gravitational pull removed the rings, then the moon
must have existed alongside it.
Must have existed at the same time.
Yeah, but how cool is that? The Earth used to have rings. Very cool. Now, the composition of the rocks found on the moon indicate that it began as a sea of hot molten rock which cooled to form the crust we see today, which is very cool. So, we're going to go and talk about the far side of the moon. So when we look up at the sky and we see the moon's face shining down, we don't often think about the dark, shadowy part on the other side.
No, I think of it as like a 2D object.
Yeah, exactly, because you never see
that. It's a disc. It's a plate.
So you never think about that part, which one prog rock band, which we've already mentioned, called the dark side of the moon. But in science, in scientific thinking, we call it the far side. This is because when the moon orbits our planet, one side of it always faces the Earth, even though it turns on its own axis. Now, I think I mentioned this in the last podcast, but that is called synchronous rotation and has occurred over billions of years as the Earth's rotation has become matched to the time it takes for it to orbit the Earth. This means that viewers from the ground can only see one side of the moon, and, until spaceflight was possible, the composition and appearance of the other side of the moon remained a mystery. What do you think the other side looks like?
I want to say something really interesting, but I just presume...
What do you want to say? I want to know.
No, I want to say that it's like,
there's a Chuck E. Cheese on the other side.
Yeah, but I know that it's just going to be very similar to the side we can see.
Well, we got to find out what it looked like in 1959 when a Soviet space probe called Lunar 3 photographed the far side for the first time ever.
Lots of flash.
Yeah, they needed a big flash module. The far side of the moon was found to actually be very different to the near side, which did surprise scientists, as the far side of the moon is heavily cratered, whereas the near side has a lot more lunar seas, which are basins of cooled lava.
Right.
Nobody has physically visited the far side of the moon, but in 2012, a Chinese mission put a lander and robotic rover on the surface, which discovered that the far side's crust is also thicker. But yeah, I mean, why do you think nobody's physically visited that side? Do you think it would be dangerously cold?
I think probably just because once you put someone on the moon once, you need to do it again. You don't need to put someone there. We know it's there.
True. And they've collected all the lunar rocks they need to collect.
Exactly. It's probably more of a thing of funding.
Yeah.
Like, that's the reason we're not still putting people on the moon. It's like, we've done it. Next
funding
thing.
And potential risk, I guess.
Yeah, like, move on.
Yeah.
We've got bigger ventures. Did you see that probe that they landed on Venus? and it took 2 photos and melted 2 hours later.
Mood.
It landed and then immediately melted.
What
So
actual...
they did it
mood.
quite a similar time to the new Mars rover that's landed.
Yeah.
But it took 2 pictures and melted.
Wow. Did they manage to get the pictures?
Yeah.
Oh, well, that's good then. Still, tragic.
I know. All that effort just for it to like land and just
Just like, peace.
yeah.
I'm off. The discovery about the far side of the moon, the fact that there are more craters on there, and the fact that the side's crust is also thicker, it suggests that a dwarf planet collided with the moon in the early history of the solar system.
Okay.
After the moon had already been created, which causes the differences between the moon's cratered side and the basins on the near side.
Right.
In 2019, the Chinese Chang'e 4 mission put a lander and robotic rover on the far side of the moon for the first time. Although it's facing away from the Earth, it receives about as much sunlight as the near side. During a new moon, the far side of the moon is completely illuminated. Now, on to lunar experiments. I want to go into a little bit more detail about the experiments and tests and processes that happened during lunar landings and expeditions. Going back to the first Apollo missions, as well as taking samples back to Earth, albeit heavily contaminated, NASA crews also performed several experiments on the surface itself, like while they were there.
Yeah.
Some of you may have heard of the famous televised hammer feather drop. So, the force of gravity determines how long an object will take to fall to the ground, right?
Yes.
On Earth, in the absence of air resistance, all objects accelerate towards the ground at the same rate, irrespective of their mass.
True. Bowling ball, tennis ball, same thing.
Exactly. That is called... Do you know the word for it?
Terminal velocity.
You're looking at my notes.
I haven't seen
It's
anything.
called gravitational acceleration,
Oh.
and it's denoted by a g, okay, which is measured in meters per second squared. For any large spherical body like a moon or a planet, the gravitational acceleration depends upon its mass and diameter. There are a lot of factors. On Earth, gravitational acceleration is 9.8 meters per second squared. But on the moon, the equivalent gravitational acceleration is different because of the fact that the moon has a different mass and diameter.
Yeah.
So, lunar gravitational acceleration is 1.6 meters per second. And that means an object dropped from a given height will take longer to fall to the surface on the moon than it would on the Earth. Makes sense.
Yeah, I could guess that one.
Yeah. It's good to explain it though, you know. So if you tried the hammer feather experiment on Earth, the hammer would hit the ground first because the feather would tend to be slowed down by air resistance.
Yes.
However, when the experiment was performed on the moon, the feather and the hammer both hit the ground at the same time. This happened... Well, you tell me, Sergeant White, why do you think that happened?
Because there's no air, so air resistance is obsolete.
Yeah, exactly.
There's no atmosphere, is probably a better way to describe it.
Yeah, exactly. So that happened because the moon has virtually no atmosphere at all. So there is no drag on a falling object, whatever its shape. And that experiment was actually broadcast live from the moon to the Earth and was viewed by millions. And we actually have a sample here. For all of you watching this on video, you can watch it with me. And for all of you listening, you can hear Commander David Scott perform the live demonstration. So here we go.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery
My man Galileo.
about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Did they?
They did, yeah. Hang on,
How
I'll go
did
back.
that feather hit first?
How
Would you look
cool's
at
that?
Yep.
I'm more surprised that they could actually get a live stream from the moon.
Why?
I don't know. I guess there are satellites on the Earth and they reach the moon as well.
Yeah, it's closer to the satellites.
Just get on Periscope, like,
Better
hey guys.
I was
But-
quite interested on that video on the sidebar.
What was...
Goat defies gravity walking up sheer wall.
Okay, we're going to watch that later. Back to the podcast, though. How fitting for Goat Any Last Words.
I know.
Now, NASA astronauts have also taken technology to the moon's surface, which has also told us exactly how far away the moon is from the Earth. And this piece of technology is called a ranging retroreflector. The reflector is part of the Lunar Laser Ranging Experiment launched in Apollo 11, allowing pulses of laser light to be bounced off the moon directly back to the Earth.
Right.
The round trip for the light pulse, travelling at 300 million metres per second, takes just over 2.5 seconds. So it's like pew pew. The concept of the experiment is relatively simple. So the retroreflector unit left on the moon is about the size of a briefcase, and within it is a series of corner cubes. And these fused silicone cubes have one flat surface. On the opposite side, there are 3 flat surfaces intersecting at perpendicular angles. And this shape enables us to send the light straight back to its source.
Yeah.
Now, that is hard to describe over a podcast, so please do Google what a ranging retroreflector looks like to all of you listening, because it's much, much clearer when you see a picture of it. Large satellites on Earth beam pulses of laser light to the retroreflector, which bounces it back to Earth. And this beam is said to be 6.5 kilometres wide. Scientists saying that this is a challenging feat and is the equivalent of using a rifle to try and hit a 1-pence piece that is 3 kilometres away and is moving slightly. So that's how...
Wow, yeah, that is...
It's a bit of a feat.
Yeah.
But it now means that we can measure the distance to the moon with millimetre precision.
Wow.
And that piece of kit is still there.
Yeah,
because
I watched an episode of The Big Bang Theory where they tried to hit it.
The measurements of the round trip time can be performed to sufficiently high accuracy to show that the moon is actually drifting 3.8 centimetres away from our planet every single year. It's estimated that it will continue to do so for around 50 billion years, and by the time that happens, the moon will be taking around 47 days to orbit the Earth instead of the current 27.3 days. Slowly but surely, that orbit length will be getting bigger and bigger due to 3.8 centimetres a year. Now, on to the interesting part of the podcast. Could we live on the moon? Now, we know that the environment of the moon is harsh. There's no atmosphere, meaning that there is no air to breathe, and the temperatures on the surface are very, very extreme. And there is also less gravity on the Earth, and moonquakes are a common occurrence. I didn't know there was such a thing as moonquakes, but there we go. However, water has been found on the moon, and scientists are optimistic that this will make it easier for humans to develop a permanent presence on the surface.
I mean, I don't.
I wouldn't drink it.
I mean, not even that. The fact that 80% of our Earth is covered in undrinkable water, 60% of the Earth's fresh water supply is in Antarctica, the one place we can't go, and we're looking at a big porous hunk of rock and they found like a drop and they're like, yeah, we could do it. No!
You seem like a moon habitat
I
skeptic.
just think if you look at this big blob of Earth that is covered in water and we don't even have enough fresh water there, there's like, it's not like they have lakes. It's like they probably just cracked open a rock and there's like one tiny little speck of...
Like condensation.
Yeah.
Yeah.
I don't think that helps us be able to live there. People don't even have clean drinking water in a world where 20% of it's land and 80% is water.
Very true. Very, very true. That's quite an interesting point to make, but we'll see what the scientists
Very
say.
good WaterAid advert out at the moment.
Oh,
I
really?
don't know if you've seen it.
I've not seen it.
It's
no.
about this girl, presuming to be in a third world country which struggles to get clean water, listening to a radio, and it says that they found water on Mars, and basically the point of the advert is if we can find water on Mars, why can't we provide clean water to the people of our own world?
Well, exactly. I feel bad continuing to speak now, but you know what?
It's an important message.
I've got
WaterAid
to.
is a very important charity.
Very, very important. Very important. So we'll keep that in mind when we're talking about the water resources available on the moon. Like the ethics of it is very interesting angle to look at. So yeah, as I said, the scientists are optimistic that it will make it easier for humans to develop a presence. The idea that man should have a permanent presence on the moon has been revisited recently as space agencies are looking to put humans on the surface of Mars. Now that brings its own challenges, but it is believed that a permanent base on the moon could become a stopping point for astronauts on the way to Mars.
I mean, why?
I think that I'm going to go into it.
No, I mean, here's my personal opinion though, right?
Okay, yeah.
It takes 4 years to get to Mars. I think. From what I remember roughly, it takes 4 years to get to Mars. It takes how long to get to the moon? I think we're talking hours.
Yeah.
So what's the point of stopping at a service station 10 minutes from your house on a 4-year journey.
A round trip to Mars takes 21 months.
So is that not nearish 4 years? 2 years?
So that would be there and back, a round trip. So it takes about a year to get to Mars. So I think the idea is that Mars, the moon being a stopping point to refuel and rest.
Refuel? There's no fuel on Mars.
But it could be put on Mars and stored there.
But it's literally like 10 hours from where they started. Like, what's the point of, on a year-long mission, having one stopping point on the first day and then having to go 365 days with nothing?
Well, let's go through the rest of the Bronze Space syllabus content, and then we'll see what you think. See what the scientists lay out for us.
You gotta convince me.
Oh, I don't take a stand on this in any way whatsoever. I just want to deliver the facts.
Yeah.
But yeah, we'll go more into it. So, the discovery of water on the moon means that astronauts could mine the water and use it for drinking, making oxygen, and rocket propellant. Now, that's the idea that the scientists have purported. Any moon settlement would need to be as sustainable as possible to reduce the need for long and expensive cargo deliveries from Earth. 3D printers could also be used to build the base by using material like lunar rock, which is already found on the moon. It's there for you.
So we're just going to use the moon to build on the moon?
Yeah.
I guess.
I mean, we use rock from the Earth to make buildings to live on the Earth.
I guess it's bigger, though.
I know, but astronauts would probably have to be sheltered under layers of moon rock to protect them from radiation and micrometeoroid strikes. So we would basically need to be underground. Now, I'm going to go through the environment of the moon and 4 factors which alter the possibility of humankind being able to make up digs on the moon's surface. So let's go with gravity first. Okay? So we're basically going through some of the points you've already brought up about what issues there may be.
Yeah.
And the realistic, how much sense it makes. So first of all, gravity. The moon has its own gravitational pull, which prevents people and objects from floating away, like they would in open space. But the gravitational pull on the moon is only about 17% of that found on the Earth because of the moon being much, much smaller. Astronauts visiting the moon have been able to walk on the moon because of the gravity present, but they could jump higher and for longer than on Earth as the gravitational pull is so much weaker. So, as human beings, we're so used to gravity being how it is on the Earth that if we were to move over to the moon and we had to regularly potentially spend time on the moon's surface, that change, the fact that the gravitational pull on the moon is 17% of that found on Earth, that's going to throw you. And it could mean that mistakes happen, injuries happen, accidents happen.
All I'm thinking is if you get on the wrong side of someone, they're just going to kick you really hard and try and push you out of Earth's gravitational... Not Earth's gravitational, the moon's gravitational field.
It could
and you're going to float away. Also, is no one thinking about the fact that if we move there, our muscles are going to atrophy? Do you remember where we talked about the ISS?
Yeah.
And how like they have like massive issues with muscle atrophy? I don't think we actually talked about it on here. I think we just talked about it in our own lives. But they have massive issues where muscles of the astronauts will waste away because they're not using them, because our bodies are used to maintaining themselves with a certain amount of gravity. Like moving your arm up against gravity is what we need to maintain these muscles. That's not going to be out there, so you're going to have a bunch of like noodle people up there.
I think in my head I've got all these sort of technological ideas they could do to offset the gravitational problem, but ultimately that is a big problem. They can't just create their own Earth-like gravitational pull inside the building.
I think people have this idea that they're just going to like build a house under the moon, and you float on out of your little capsule and walk in, take off your suit, and you're like, you're right. No, like everything is different. You have no atmosphere. You have no gravity.
Yeah.
Your muscles are constantly wasting away for what?
Really passionate about this. Okay, next factor, temperature and atmosphere. So the moon's surface temperatures are very extreme, and it can vary from minus 233 degrees in the dark to 123 degrees in full sunlight.
Again, not selling it to me.
I'm not trying to.
Okay.
I'm just giving you the facts. Stating the facts here. You seem to be extremely passionate about this, and I'm not one to stop you, so I'm going to continue.
So at night, I'm a Calippo, and in the day, I'm like a barbecued rack of ribs. Where's the sweet spot? Earth is the sweet spot. Earth is the sweet spot.
Well, we all know Sergeant White's opinion on this. So, This extreme temperature change, this is because there is no atmosphere to help regulate the temperature like there is on Earth.
Yeah.
The atmosphere on Earth acts like a blanket which traps the heat so that after sunset, the surface temperature falls relatively slowly. When the sun sets on the moon, the temperature drops very rapidly. The moon is unable to retain an atmosphere because there is insufficient gravity to hold onto light gases for long enough, and there are no life processes like plants or animals to regenerate an atmosphere.
Yeah.
So the atmosphere on Earth is perfectly tailored to supporting human life, almost as if we should stay on this planet.
Yeah, almost as if it was made for... I mean, I'm not...
Right, intelligent design.
No, I wasn't saying like God made it. I'm just saying like it's almost as if that's where we should stay.
Yeah, exactly. So anyone visiting the moon would have to deal with these temperature differences with special clothing and equipment. The lack of atmosphere means the surface of the moon is unprotected from cosmic rays, meteorites, and a fine spray of hydrogen and helium atoms that are continuously being ejected from the sun, and these are called solar winds. So the moon's surface is unprotected from any of these because of the lack of atmosphere. So that's just a permanent, constant source of danger. No sound can be heard on the moon as well, and the sky always appears black. So you can't just open your window, turn on your music, and have a sing, because first of all, you'd die, and second of all, you can't hear that song that you love so much, which is really sad. I couldn't do it. The blue sky and clouds on Earth. What? Why are you laughing?
You couldn't just open your window, switch on a song. I couldn't do it.
So, our final factor is moonquakes. So, the moon has moonquakes, and lunar astronauts used seismographs on their visits to the moon and found that small quakes occurred several kilometres below the surface, causing ruptures and cracks. It is thought that the moon has a molten core, just like Earth, and that quakes are caused by the stresses that are created by the gravitational pull of the Earth on the moon. And this would have to be taken into consideration when building more permanent structures on the moon, as they could become damaged by these tremors. Now, moving on to water on the moon, which is a topic that Sergeant White is extremely passionate about. So, lunar science is undergoing a shift as increasing evidence disproves a theory from the Apollo landings that the moon is a dry and waterless object. So, since these initial missions, water has actually been found at both poles of the moon and on the lunar surface by probes and rovers. And there is mounting evidence that the lunar poles may hold vast amounts of water ice. Now, this ice is trapped by the extremely low temperatures present in craters that never see the sunlight and are therefore in a permanent shadow. So, minus 200 odd degrees Celsius. So, permanently frozen, trapped away. The absence of sunlight means these regions near the poles are some of the coldest places in the entire solar system. And other later missions have detected low concentrations of water on the lunar surface outside of the poles as well. And this means that water is even more abundant than was thought of previously.
You know what I think happened?
Go on.
A bunch of water just splashed off us and went onto the moon.
How would it have splashed?
During the asteroid that killed the dinosaurs.
Good theory.
I think there was just a massive splash.
Like a big puddle.
Yeah. I mean, they're finally getting like random places. Top, bottom, a few bits around the edge. It looks like a splash mark. Just saying.
Cool, that's a good theory to me. I like it. Okay, so we're going to be looking into some projects which try to find out about the water content and water sources available on the moon. And the first one was the LCROSS mission. And LCROSS stands for the Lunar Crater Observation and Sensing Satellite. And this was a spacecraft launched by NASA in 2009. And this was a relatively low-cost way to find out whether water was present at the poles of the moon. It landed inside a permanently shadowed crater on the south pole of the lunar surface and detected a significant amount of water inside the crater. The spacecraft was made of two parts. The first part was a large rocket which contained the fuel for the mission, and this part was purposefully crash-landed into the crater at approximately 9,000 kilometers an hour to throw up a plume of debris 10 meters into the air. Now, the second part, which contained the scientific instruments, that part broke off from the rocket section to monitor and record the debris that the rocket had thrown up. Now, this monitoring craft was called Centaur, which I like that name.
Yeah.
NASA's really good at thinking of names for
They're quite,
moons and
yeah, ingenious.
I like it. Now, another project, the Sophia discovery.
Oh.
And SOFIA stands for the Stratospheric Observatory for Infrared Astronomy. Really, really proud that I said that right in one go. So that is a converted 747 aircraft that flies at very high altitudes above much of the Earth's atmosphere. And in 2020, so not long ago now, it detected water on the sunlit surface of the moon. Now, this discovery indicated that water is distributed across the lunar surface and not just limited to those extremely cold poles of the moon.
Oh, so there goes my splash idea.
There goes your splash. Sorry, sunshine. In the area studied, scientists established that per cubic metre of soil there were around 350 millilitres of water. So an infrared telescope on board Sophia detected the water, and NASA believes that it is stored in bubbles of glass or between small grains of rock on the surface, and that is why it's been protected from being lost to the harsh environment of the moon and space. Now, although that this discovery is significant, it is still thought that the moon is 100 times drier than the Sahara Desert.
Again, why do we want to go there? No one's like, you know what's a really great property development area? The Sahara. So why are we thinking about the moon? You can get a car to the Sahara Desert. You can't get a car to the moon.
I know. I think that I personally think that it is an interesting venture, as it could be a place where equipment and fuel could be stored.
I think people like just being the first. People want to be the first to do things. People
the first people on the moon, that was kind of a big deal.
I mean, that was a big deal, but people like to do things that like they're told they can't do. Like if someone says, don't touch it, it's wet, people are going to touch it. If people say, I don't think we can live on the moon, they're going to be like, watch me. I'm going to...
Wasn't it Einstein that said the stupidest ideas are often the best ones? Or something like that? I'm definitely misquoting there, but
yeah.
You never know, you've got to be ambitious.
That's true.
Who knows? 50, how many years ago? 70 years ago, people were probably laughing at the thought of walking on the moon. Because everyone thought it was made out of cheese. But yeah, you've got to dream.
I don't think people that were born 70 years ago really thought it was made out of cheese. Give them some credit.
Live to dream.
That's what I'm saying. There were some probably quite intelligent astronauts
All I'm
around
saying
those
is,
times.
Live to dream, Sergeant. Live to dream. Now, 100 times drier than the Sahara Desert. So, the water is also contaminated with other substances like methanol, but scientists are confident that it can also be processed to make it drinkable.
Great, so it's not even drinkable.
Well, of course it wouldn't be drinkable.
Might as well have found.
Most water on the Earth isn't drinkable until we filter it and
I said that, didn't
kill
I?
the bacteria.
No, 60% of the world's freshwater drinking supply is in the Antarctica.
Mm-hmm.
In the Antarctic, even.
So, finally, I'm going to very, very briefly discuss the plans that the European Space Agency have for the moon, and that is for making it a base for Mars. Now, I'm not going to speak about this for very long because we're planning a very special, massive episode solely on Mars. So the World Space Agency is seeing the setup of a permanent village on the moon as a first step towards exploring Mars. So not thinking of the moon as a place to dwell in its own right, but using it as a stopping point on the way to Mars. Now, the ESA says that the moon is the right place to be as humans expand economic activities beyond low Earth orbit, with Mars becoming the ultimate destination for manned space travel. Any future lunar base would probably need to be located close to the permanently shadowed regions of the moon and on its north and south poles. Now, that's because that's where most of the water is, albeit frozen and contaminated.
Which is weird because when you think about the way that Earth is set up as well, both poles frozen.
Yeah.
Loads of water.
Yeah.
So I guess that proves the fact that poles are cold and the equator's warm. What?
To reduce the cost of space missions, in situ resource utilisation, or ISRU, is seen as a way to use materials found on the moon instead of taking them from the Earth. Now, if, this is a very important word, if water is proven to be found on the moon, then extracting this water and using it would vastly reduce the cost of space exploration. So if, in theory, they were able to decontaminate, purify, and make that water drinkable, it could be invaluable to future projects and would make them a lot cheaper. Astronauts could mine the water and use it for drinking, making oxygen, and rocket propellant.
See, I don't believe that, but if they've said it, I guess it's true.
They might know a tiny little bit more about it.
Or they might just want to do
Not
it.
to insult you in any way,
No, they
but
might just want to. They might just want to do it though, so they're selling it. I don't believe that it is cheaper to build like a shelter on the moon and man it with astronauts. And they're talking about, oh well, if we have like, you know, water on the moon, then we can make oxygen that they can take on with them. What are they breathing when they're on the moon? They're gonna have to take oxygen out with them from Earth, aren't they? Are they not?
I'm not too sure, but this is very lively debate, and I want to hear what the cadets think as well. Do you think that using the moon as a base is a realistic venture? Do you agree with Sergeant White? Are you unsure like me, or do you have a different opinion?
I mean, oxygen is a commodity. Like, during this pandemic, right, there have been many different countries, especially countries that aren't funded extremely well, that have had problems in their intensive care units where they've literally ran out of oxygen, like canistered oxygen, because it's such like a... I remember when I was at work, someone had left the bagging circuit on that had like a litre of oxygen running through it, and someone came around and like turned it off and like told them off because like we were...
I don't blame them.
Leaking oxygen into the... I mean, we have oxygen running at a litre, like that's not a big deal, but like that's the value that oxygen has during, you know, a pandemic where more people per hospital are on high oxygen requirements. So you're telling me that then us sending all these astronauts up to the moon to man a base to make some water isn't just easier than just doing it here? Because we get the oxygen for free. Yeah. We just breathe it in with our lungs. It's not like we have to put it in a canister and send it up to the astronauts up there. I just feel like it's easier to do it down here.
Well, there we go. That's what Sergeant White thinks, but what does everyone listening think?
So I will not be putting my stocks in that.
Fair enough. Now, there's a lot more to go into in terms of thinking about the moon as a base for Mars travel. There's things about using the tools available on the lunar surface for 3D printing a base, living underground, as I aforementioned, and the actual travelling to Mars. But we're going to save that for our other podcast episode, which we are going to do solely on the Red Planet.
Because I have something to say about that as well.
Well, I no doubt bet you do.
I do.
Very good. Well, I look forward to listening to that. Now, that is the main content, but we're going to do some more trivia questions.
Okay.
So in our last podcast, I introduced this where I'm going to do 5 bits of trivia at the end of each episode. You guys are going to guess what you think the answers are, and Sergeant White will, and then we'll let you know the answers. Because during this pandemic, we've all grown to love quizzes. Now, maybe a little bit too much, but, you know, thought I'd introduce a little bit of trivia.
Do you know what's a really good thing to do if you have a couple of spare minutes?
What?
Go on to Google Trends. You know, where you can like search the trend of a word. Search the word quiz. It goes over 5 years. Every year at Christmas, you'll see a small spike.
Yeah.
Look at March of 2020, and it shoots up massively.
At the beginning of the pandemic.
Yeah, and then slowly comes all the way back down again until November, December, when it shoots up a little bit again, and now it's just flat again. But, like, who knew that the quiz was going to spike during a pandemic?
Well, there
never
you go.
before, I bet. Never before. Pandemic, what was it, Spanish flu of 1918? I bet they weren't doing quizzes.
No, they were just wearing really weird-looking masks. I don't know what else they were doing. Maybe
Weird
they were
masks.
Yeah, I've seen pictures of people during the Spanish influenza, and they wear the strangest looking masks. Ones that look like cones, ones that look like plague doctor masks. And what I want to ask is, why didn't we get on that during this pandemic? I want a plague doctor mask that's fully functional.
Well, you've got adult money. Feel free to buy
Well, it's going to happen.
Get yourself on Etsy.
Well, okay, so we're going to go through the 5 trivia questions I've got. So, cadets, make sure you're listening. The experiment streamed live on national American television using a hammer and a feather from which bird? In what year was the L-Cross mission? What does the giant impact hypothesis state? How many centimetres is the moon drifting away from the Earth each year? And finally, in what year did the Soviet space probe Lunar 3 photograph the far side of the moon? Okay, Sergeant White.
Right.
Question 1. The experiment streamed live. What type of feather did they use?
Falcon.
Falcon. And why did they use a falcon?
Because the thing was called the Falcon. The lunar landing module was called a Falcon.
Brilliant. And then also, if you look at the Apollo 11 patch, they have a falcon on that as well.
Yeah, because
and his claws are scratching the lunar surface.
Yeah.
That's actually how they mined the lunar soil. They got a falcon out, used his sharp claws.
Don't, because the cadet will think that's true.
That is not factually correct.
It's an educational podcast.
So next question, Sergeant White. In what year was the L-Cross mission?
2009.
2009, that's correct. And do you remember what L-Cross stands for?
No, I do not. The
Well,
Lunar Crater Observation Sensing Satellites.
Okay, you just read over my
Yes,
shoulder,
I did.
and that wasn't even right.
No.
The Lunar Crater Observation and Sensing Satellite,
I know what they did.
launched in 2009. Brilliant stuff. Okay, next question. What does the giant impact hypothesis state?
Is that the one that brought into play the grating angle and stuff like that?
Grating. No, that would prove that the moon was made of cheese. Grating, not the grazing angle. Yeah,
Grazing
you're pretty
angle,
close. So the giant impact hypothesis stated that the moon was formed by a massive impact between a proto-Earth and an object about the size of Mars.
Yeah, okay.
And it approached it from a grazing angle.
Grazing angle, not grating.
Grating angle's better, though. All I can think of is just a big chunk of cheese. Next question. How many centimetres is the moon drifting away from the Earth each year?
Well, I thought in a previous podcast you told me that since the moon was around, it's only drifted 2 centimeters away from the Earth, or 2 degrees away from the Earth.
That's degrees, not centimetres.
Right, so 2 degrees away.
That would be on its own axis.
Okay, so I'm gonna guess. Is it a whole number? Have you told me?
Yeah, I mentioned
Okay.
it. Everything that we cover on the trivia has been discussed during the podcast.
Is it like a whole number? It's not like a.
I'm not
point.
giving you any
Okay.
hints.
I'm gonna guess. Every year. 0.5 centimeters.
Have you been listening to me? It's 3.8 centimetres.
Damn.
So every year, the moon has been slightly drifting away from the Earth by 3.8 centimetres. Can you remember the name of the machine used to measure the distance between the moon and the Earth?
I can't remember the name of it, but I know it's basically a briefcase-sized reflective panel using some kind of snazzy nanocubes to reflect back.
I like that discussion.
Within millimeter
There's
precision.
a ranging retroflector.
Yeah, never gonna get that.
There we go. Finally, in what year did the Soviet space probe Lunar 3 photograph the dark side of the moon?
I'm gonna go like 79.
79.
You wrote this, do you not know?
I do. It was 1959, so it was before the Americans walked on the moon.
Oh, I thought it was after.
And that Soviet probe was called Lunar 3. So there we are. I hope that the cadets listening did better than Sergeant White. He didn't do badly.
I think I did
He didn't
quite
do
well.
badly. You were very, very specific about the briefcase with nanocubes. I liked that.
Yeah.
Brilliant stuff. So there we go. That's the moon. Next week, we'll be covering another plane crash. But we're not going to reveal which one it is. I think that can make it a little bit of a surprise, can't we?
Yeah.
So look forward to that. But thank you very much for listening. Make sure that you follow us on Spotify as we release this podcast every single week, and subscribe to our YouTube channel as every single Friday we premiere a new episode. But thank you very much for listening, and goodbye.
Bye. Thank you for listening to Got Any Last Words, a weekly podcast for Air Cadets, released every Friday. Got Any Last Words was written, produced, and presented by Sergeant White and CI.me of 361 Cadets Squadron. Sound effects by Motion Array. Podcast theme is Grow by KV.